Hello students, today we will discuss about some concepts related to friction, and then as usual we will do one simple experiment, but a nice experiment to validate our concept. So it's better to know the experimental facts behind each concepts. Consider we have one surface S. On the top of it we have an object B, and we try to slide or move the object B on the surface S by a force Fa as shown by this arrow. Consequently, we know that there will be an opposite force which is parallel but in the opposite direction to Fa, and this force is Fb we denote, and this is called frictional force, which will be acting through the interface between two surfaces. Now how to define this frictional force? This frictional force Fp is equal to mu times R, where R is a force perpendicular to the surface, and this force is with a magnitude, it should be equal to mg, which is the downwards weight of the object B, and mass of the object is basically m, and g is the acceleration due to gravity. So Fb should be equal to mu mg, where mu is the frictional coefficient, which depends on many factors such as the relative motion and most importantly on the roughness of that surface S, which will come to the later. Now let's extend this idea for an inclined surface. Let's consider we have an inclined surface S, and this inclination angle is basically theta. Now again we imagine we have the same object B on this inclined surface, and essentially the weight of the object is mg, will be straightway downwards, and this weight or this gravitational force can be divided into two components. One is parallel to the inclined surface S, this is Fa, it should be equal to mg cos theta, sin theta, and another force component will be mg cos theta, and this is equal but in opposite to R. Essentially R should be in magnitude equal to mg cos theta. Fine. Essentially we know that frictional force will be acting parallel to Fa but in the opposite direction, and this is Fp should be equal to mu times R from the above relationship Fb equal to mu R. So in the equilibrium condition, when the object is just about to fall but hasn't started falling, in this case Fb should be equal to Fa. This is the equilibrium condition, we have to remember. So in this condition Fb equal to Fa, then we will have mu mg cos theta equal to mg sin theta. Therefore sin theta by cos theta equal to mu, so tan theta is equal to mu, therefore theta will be proportional to mu. So this is an important relationship, theta is proportional to mu, meaning for a small mu theta will be small. What it means, that if we have a and for large mu we have theta large, Now let's consider the cases for small mu and large mu. So the inclined angle will be changed based on the mu value, which is depends on the roughness, surface roughness of the surface S. Now for an experimentally we need to see this from the experiment, that how if we change the surface roughness S of the surface S, hence we change the mu, then correspondingly we will see there will be a change in the theta to make the object slide or falling through the inclined surface. Let's we will do this from the experiment. So before going to experiment, let's once again note this, that for the smooth surface which has essentially smaller or less mu, it must have lower theta angle, means a small inclined angle can lead to the object falling, object slide. On the other hand, for rough surface S which has large mu, it must have large theta for the given object, for the same object to fall. Remember this point. So these are the conditions. From our exercise we get these are the conditions. So these two conditions we will see from the experiment if it is true. So as shown from the schematic diagrams, for the smooth surface inclined angle should be small, and for the rough surface inclined angle should be larger to make the object fall. Okay, so here we come to the experiment for a quick check of these ideas or these concepts. In our YouTube videos we will be always doing this exercise, that we will first discuss a concept and then we will see from the experiment if these are valid. So for this I made one artificial box with one surface is smooth as it covered by plastic, and another surface is with a sandpaper, and that is a rough surface. So the plastic covered surface is a smooth surface and the other surface is rough surface, black surface is rough surface. Essentially the smooth surface is small mu and the opposite other surface will be have large mu. So now I have the same object which is basically a aluminum slab. Then for this slab we will check what will be the angle of inclination to make the object. First we are checking for the smooth surface. We see for small tilt or small lifting or small inclination the object has fallen. Let's see this once again. See, it's just a small angle is you need to make this object fall. So then we find that we have some estimation what was the required inclination angle. Okay, so you can see again and again, and this is the same phenomena will be repeated. Now let's come to the other situation for the rough surface case. So we put that same object, same surface of the object on the rough surface, which is black sandpaper, and it has a large mu. Now let's see, we are going to make an inclination angle. As you can see, we are lifting more and more. Not yet fall, just fallen. So compared to the last case or smooth surface case, here clearly we see the inclined angle is large for the large mu case or rough surface case. So what are the we will repeat it again. See, it took large inclined angle compared to the first case. So this validates our concept by the experiment, from the experiment. So the experiment and theories are matching. Thanks for watching. Please subscribe the channel.